Hello everybody. My name is Thomas Krieger and I want to show you how to write deterministic unit tests for multi-threaded Java with VMLens. VMLens is a tool I wrote to write such tests, to write deterministic unit tests for multi-threaded Java, since multi-threaded Java is not deterministic and this makes it very hard to test it. To demonstrate this, I wrote a simple unit test for incrementing a volatile field, and this test shows the problem writing deterministic unit tests for multi-threaded Java. So we have a variable j which will be incremented in parallel by two threads. Both threads are calling ++ for the variable. The main thread starts the second thread and then joins it, and in between it increments the variable, so both ++ is in parallel. And in the end we check if the value is actually 2. And well, the problem is there are some thread interleavings where the value is not 2 but rather 1. So the problem is the operation ++ is not atomic, which means read and write are separate operations. ++ consists of two operations, read and write, so there might be interleavings where we have thread 1 reads, then thread 2 reads, and then that 1 writes and thread 2 writes, so which will lead to a sum of 1 instead of 2. And this makes this multi-threaded program non-deterministic. So it depends on the order of the threads. And so there might be some test ones which will succeed, and other test ones which will fail. So let's see if we can actually see a failure. But typically the most common case is that it succeeds. So the order is read write, and so typically if you simply use one test, it doesn't reveal the error. We can try it with 100, but we will see typically the most common case is that the read write. So if we increase the number to 100,000, we see that we can create such an interleaving. There are, so probably in 10,000 cases, we have an interleaving read write. But yeah, it's rather uncommon. So I think this is a problem with testing multi-threaded Java. There are cases where the thread interleavings where the test succeeds, and there are cases where the test fails. And I think this is actually a problem with testing multi-threaded Java, that it's basically not deterministic. And well, the question is, how can we solve this? What can we do to make such code testable? So what can we do? To show how it works with VMLens, I wrote the same test with VMLens. So basically we have the volatile variable, we have again the ++ called parallel, we have again the check, but this time we have an iteration over all thread interleavings. I think we have seen the problem with multi-threaded tests is that that the outcome depends on the order of the threads, on the thread interleavings. So the basic idea is, why not simply iterate over all possible thread interleavings and thereby we can make the test deterministic. So that's it. It's rather simple, I would say. To make it reproducible, to make it deterministic, we simply have to iterate over all thread interleavings. So let's see if this test is actually deterministic, and we see we have found an error. So here the one led to an error. VMLens works as an agent, so it traces all threads. We can see it by debugging. So we can see how VMLens work if we look into it by debugging. And we see every field access, every method call will get traced. And thereby this allows VMLens to calculate all thread interleavings. Now let us see that it actually executes all possible thread interleavings. So instead of a check, we make a system out to see the results. And we will see how many runs we need. And we see we have 6 runs, 4 runs where the result was 2, and 2 runs where the result was 1. And yeah, basically the first 2 are needed to trace to see what synchronization action are existing, and the last 4 are the actual different thread interleavings for this test. So basically for this test we need 4 different thread interleavings. Now in the next we will rerun the test with an assertion. Again, the test fails, so it's reproducible. It's really deterministic. And okay, now this is the report VMLens generates. We see the result of our test. In our case, it was in failure. We see the number of runs the test was executed. In our case, we had 4 runs, and we see the name. And if we click on the name, we will see a report showing all thread interleavings, so basically 4. We see the thread name, we see the operation, we see the element on which the operation is executed, and we see the object. So the first one was successful. We see read write, so everything was okay. And then we see the volatile read in the end to get the result for the check. And here we see the second one. Again we see the read and write. Again the one was successful. Actually we see also why this might be problematic, this test, because read and write is not one operation but rather 2. So yeah, as we already have seen, it depends on the order. The outcome depends on the order. Now we see a different one. We see first the parallel started thread, which executes the read write, and after that the main threads read and write. Again successful, only a different order of the 2 threads. And now we see the problematic one. We see the 2 reads, and we see the 2 writes, and yeah, this lead to the wrong test, where we have 1 instead of 2. Okay, so let's see what is happening if we remove the volatile declaration. And what is happening? So the assertion is successful, but we have a data race. Data races are documented in the Java memory model. We can look at the Java memory model FAQ by Brian Götz and Jerry Manson, where it is explained what is actually a data race. The problem is the compiler and the CPU might reorder the statements. So, for example, the CPU might cache values. The compiler is free to reorder statements to improve the performance. And it may appear if it's a different order than specified by the program. And the trick is, in single-threaded programs, this is no problem. The only time we can see such reorderings is if we have an incorrectly synchronized program, incorrectly synchronized multi-threaded program. So, however, reorderings can come into play in incorrectly synchronized multi-threaded programs. And data race and synchronize is actually the same. Every time we have an incorrectly synchronized program, we have a data race. And a data race means that we have an access to the same, read and write access to the same variable, which is not synchronized. So there is no volatile access bit in between. There is no synchronized block in between. Every time if you have such a situation, there is a data race. If you look at the CPU architecture, for example, of an AMD processor, we can see one case where such reorderings can happen. The CPU caches the values in caches, or on the left top we can see the level 1 cache, and we can see the level 2 cache and so on. And those caches will only get synchronized if we have a synchronized action, like a volatile read, write, or a synchronized block. So this is one of the reasons, one of the places where reorderings can happen. And to make tests possible, VMLens checks for data races. So it always checks, is there a data race, and if yes, it creates an error, and we can see in the report where this data race was happening. So if we look at our test, we see, okay, here the test worker and thread 3 are both accessing this variable j without any synchronized block in between, without any volatile read or write, and therefore we have a data race. Okay, now after we have seen what is a data race and how can we detect data races with VMLens, let us look at a real test, testing a real class. We test map step registry. Map step registry is a class from the Spring Batch framework. It's synchronized, so we should be able to call it multiple times from multiple threads. And we test it by calling unregister in parallel with get step in a second thread. We iterate over all thread interleavings. And so let's see what is happening. And okay, we see a null pointer exception. So let's see how we can find out why this null pointer exception is happening. Here we see map get returns null, and therefore job step contains key throws a null pointer exception. Even so, map contains key return true. And I think the problem is that map remove is in between those two calls. We can check this in the traces. So we can go to the VMLens trace, we see the failure. We see again the count, 4 iterations, and we see the step name. And if we click on the step name, we see the thread interleaving. Okay, so we go to the last thread interleaving, which led to the error. And here we see test worker first calls contains key, which then will return true. Contains key is an atomic operation, so we see the atomic read enter for the contains key, which internally calls the get method of the concurrent hash map. Again, the enter, then the exit, and then the exit of the contains key. And this, since the step is still in the map, returns true. And then thread 6 calls remove, again enter and exit. And then after that, the test worker calls get, and this get then will return null since we already removed the step. So this is the problem. This is the cause of the null pointer exception. We can again look in the source code to see the problem. We see here the test, and now let us look at in the source code. Here we see the map contains key returns true. Then we call map remove, which removes the job, and then we call map get, which is obviously null. And I think this is the problem. And again, we see it's a non-atomic method. Get step is non-atomic, and by iterating over all thread interleaving, we can find such race conditions. Okay, so the last test, let us look at deadlock. We test concurrent sequence map, which is a class from the Hero open source project, and we call the method put if absent in parallel by 2 threads for different keys, and see what is happening. Again, VMLens executes every thread interleaving, so and then one interleaving had a deadlock. Since we have a deadlock, it stops, and it prints out the trace of the stack trace of the deadlock. Okay, so as we have seen, we can detect deadlocks, we can detect data races, and we can detect race condition. And that's it. Hope you enjoyed. Hope you want to write use VMLens to write your first deterministic unit test. Thank you. Here are the links for the repo and for the examples. And if you have any questions, feel free to contact me either by LinkedIn or by email. Thank you.